talking about function notation today. Now, function notation is a concept that you can make really complicated if you choose to. But all function notation is another way to say y. And actually, it's not another way to say y, it's another way to say output. So when we think about our variables, right, we have x and we have y. That's what you've normally seen. But really what x is the input, and y is the output. Okay, so x is what I put in to the equation, and y is what I get out of the equation. So if you think about it like that, the equation is like a machine, like a meat grinder. I know this is going to sound like super gross, but like let's say I have meat, like beef, and I put it in the meat grinder. What comes out? Ground beef, right? If I have pork and I put it in the processor, I get out ground pork. If I put in a tire, I put it in the meat grinder and I get out a ground tire, okay? I get rubber chunks, whatever, okay? So the machine, all the equation does is process my x and tell me what y is. Sometimes I have to go the other way. Now, obviously, with a meat grinder, I can't take ground meat, stick it back in the machine, and have, like, it's just like you can't unhave a baby, all right? Like, no matter how much Molly makes me crazy, we cannot take her back, okay? We cannot unmake her, okay? So, but with an equation, we can work backwards, okay? So, all this means is that I'm making another name for output. So, x is still input. F of x is another way we say output. And I've had a lot of people today ask me, like, when are we going to use this? Well, there are skills that we learn in Algebra 1 that aren't necessarily Algebra 1 necessary skills. We're learning function notation because it's something you have to have on lock when you get to later grades. And it's really something you need to have on lock when you get to physics. So we practice function notation in Algebra 1. It's a supporting skill. So it supports a later skill that you need. We practice it in Algebra 1 so that by the time you need it in your later math classes and some of your later science classes, you've got it on lock. You're not like, what is this? Okay? Now, you might not just see f of x. You might see g of x, which would have an input of x. You might see h of t, which has an input of t. So tell me something that you notice about function notation here. Yeah, and what replaces x? The thing inside the parentheses is what replaces x. So, what if I said f of 3? Then my input would be 3. Means I'm putting a 3 in, I'm getting out f of 3. Okay? So, when I use function notation, f of x just replaces my y, or g of x, or h of t, or q of r, who knows what it is. Okay? They all just mean x. And what this actually says is y is a function of x. That's why we say f of x. So, it says y equals f of x. Literally, if you read this math sentence in English, it's y is a function of x. That's literally what this sentence reads. Y is a function of x. So, that's why when we actually look at this equation, that's why whatever's by itself is my output variable, my dependent variable. So we call the output variable dependent. And the input variable independent. You'll need that for tonight's homework. Okay? So what do we think? Does it seem hard so far? Good, because it's not. This just becomes f of x equals 2x minus 5. That's it. F is the name of the function, actually. So this function's name is f.
Wait, so it's just rewriting y.
Basically, it's just rewriting y. Now later on, when you get to some of your later classes, it might get a little more complicated because then you're going to be dealing with other constants and stuff like that. But that's somebody else's problem. Not to say to anybody listening that I don't consider that to be my problem, but That is a problem for a later class. That's an issue, like dealing with more complicated things besides y being f of x, something you'll deal with later. We need to practice this now so that when the equations do get more complicated, you got it on lock. And we'll see a little bit, just a tiny bit of it when we get to quadratics, just the tiniest bit when we get to quadratics, but we won't really do much with it. Okay? So let's take a look down here. So if I look at this first problem, now, you can solve these by hand. There is nothing wrong with that. But function notation is a good opportunity for us to use our calculators. Second period, I was like zipping along on my calculator. They're like, what are you doing? So it occurs to me that maybe y'all didn't use your calculators last year as much as I thought you did.
Oh, no, we barely.
Okay, so I'm going to very quickly, I'm going to show you, I'm going to walk through how we would use our calculator to put an equation and look at a list of values. Okay, so for those of you who are like, but I don't want to use my calculator, I don't care. You are responsible and expected. The expectation, the state of Texas expects you to be able to use this calculator, so you need to get it if you don't have it already. Okay? Okay, so let's make sure that we're following along. Okay, so first of all, remember we clear RAM by second plus 712. You just put those buttons. So let's clear RAM now on your calculators. Because I want us to make sure that whatever crazy nonsense the last person did, that you have to do it all yourself. Because you have to know how to do it. Okay, so anytime we want to enter an equation and look at its list of values, we always go to y equals. Whether it's f of equals or f of x equals or not, we go to y equals. Okay, and in y1, we're going to put the equation. Now later on, we'll start using more than one row, but for today, we're using just one. 3x plus 4. Remember, for x, I'm going to use this xton button right here. That's my input button. Okay? Now, there's a couple things I can do with this data. First of all, I can just hit this graph button right here, and it'll show me a graph. The graph has its place. I'm not terribly fond of the graph, and let me tell you why. Because there are a lot of things I do with the graph. Okay, but finding precise values is not it. Because if you notice, like right here, you notice how these two are closer than those two?
Yeah.
And like these two are closer than those two, and this one's really far. Like they're not. And like these two, it's not precise because of how low resolution this little screen is. You can't really precisely graph points, even if you turn the grid on behind it. You just can't tell. So I like to use the table instead. Since the table is in blue, I hit the blue, which is the second button, and then graph to get to it. So this generates a list of values for me. Okay? Yes.
When doing two equations, don't we put one in y2 and then we match them to get the same thing?
Yeah, kind of. There's a whole lot of things we're going to do with two equations. Yeah. Yes, what he was saying was if I want to solve an equation, so let's say I want to find 3x plus 4 equals 7, and I look at the table, I look for the row where y1 and y2 are equal to 7, but that's not what we're doing right now. We're not solving equations. Oh, God, that just happened. We're not solving equations. We're specifically looking at a list of values. So, since x is my input, right, what would y1 be for our purposes? Go ahead, say it louder. F of x. It would be f of x. y1 would be f of x. So another thing that we can add to our thing here is we have x and y1. Okay? So when I'm looking at a table, I'm going to have x and y1. So in this case right here, for this problem, did they give me input values or output values?
Input, output. Sorry, no. Input. Output.
Why are they input? Because they're x, but they're also inside. They're input values because they're inside. Okay, whatever the number is, if it's inside, it's an input value. Like over here, is this number inside? It's outside, so it's an output. Okay? So here they gave me inputs, which means if I thought about this, I could think about this like it being a big old table. X and Y1. So what is 5? Is it an X or a Y? It's an X. What about 2? It's an X. What about 0? Also an X. -1, also an X. Because they're input values because they're in the place of X. Okay? So now all I'm going to do is I'm going to look in my calculator. If I want f of 5, I want to find what is x when x is 5. What's y? 19. When x is 2, y is 10. When x is 0, y is 4. And when x is, okay, that didn't work out. When x is -1, y is 1. Okay? So we would write this. Here's how we would write our answer. f of 5 equals 19. For this one, we'd write f of 2 equals 10. But what do I write for f of 0? F of 0 equals 4, and f of negative 1 equals 1. Okay? Now, I want you guys to try that one. Try the next one. Take a minute. All right, so hopefully you got the same values I did. F of 9 equals 3, f of 6 equals 2, f of 0 equals 0, and f of negative 3 equals negative 1. Right? Yeah, okay. Now, what's different about this last one? What do they give us instead of the x?
Output.
They give us the output. So that means instead of looking in the input column on my calculator, I'm looking in the output column. So in this case, I'm looking at y. So I'm going to first put the equation in, which is 3x plus 4. You hit y equals to go back. And then I just hit the clear button to clear out the row. And then I hit 3x plus 4, and then I'm going to hit second and graph again, because again, I want to look at the list of values. So, am I looking, okay, so tell me, am I looking here, or am I looking here?
Here, there.
First or second? It's like, is it better here or here? Okay, the second one, because I'm looking at the output value. So, I would say x equals negative 3. Or I could say f of negative 3 equals negative 5. Okay, it's both the same thing. Okay, let's try and find the other ones real quick. I put the equation in y1. Okay, 3x plus 4, just like is on the paper right here. I used this equation. And then I went to the table, second graph to the table, and then I looked for these y values they gave me. So they gave me y1, so think about this is y1 equals negative 5. Well, when y1 is negative 5, x is 3. When y1 is negative 2, x is also negative 2. When y1 is 7, x is 1. And when y1 is 13, x is 3. I could also write that f of negative 3 using function notation. So I might see either of those answers. All right?
Does it give you the table? The table?
You can totally do the table. Just make sure you circle which one is the answer. So for the last one, this is actually, so you were asking, do we have to do the table? This is a situation where using the table is actually kind of helpful. So for this one, right, they're giving me kind of a mix of stuff. So they're saying, for this function, I want g of negative 3. Is that an input or an output?
Input.
They gave me an input. What is the input they gave me? Negative 3. It's an input because it's inside. What about g of negative 1? Input of negative 1. G of 2. Input of 2. G of x equals 8. Output of 8. Okay, so you see why putting it in the table here kind of helps. So what I'm going to do, honestly, just to help me finalize my answer, I'm going to put big circles in the stuff I'm looking for. And then what am I going to do? Y'all tell me what I'm going to do. What am I going to put in the calculator?
The equation.
Where do I put the equation?
Y equals.
So I go to y equals, and what do I put, and where do I put what?
In y1 you put 5x
5x minus 2. Okay, and then where do I go?
second graph.
Second graph to look at the table, and then I'm looking for these values. So negative 3, I have a y value of negative 17. Negative 1, I have a y value of negative 7. 2, I have a y value of 8. And then when y is 8, I have a x value of 2. What do you guys think? Okay. Are some of you going to overcomplicate this? Yeah, you are. Some of you are already overcomplicating this, but this is literally all it is. Okay? It's just calculator stuff.